I'm Anil Kumar, and in this video we will learn simple steps to sketch complicated transformed sinusoidal functions. The question here is, sketch one cycle of y equals to 2 sine half of x plus 30 degrees plus 2 over 3. Now this sinusoidal function has all kinds of transformations. If we understand how to sketch this one, we'll be able to sketch most of the sinusoidal functions. In these set of videos, you'll find many examples to practice. Now, let us begin by understanding how to sketch graph of such sinusoidal function. First step is to find time period. That is the first step, to find time period. Now, what is time period means? Period for one cycle. So we are going to sketch just one cycle. So let us find time period for one cycle. Now that is given by, since we are working in degrees, time period t in this case will be 360 degrees divided by this number. This number k is half, right? So that gives us 360 divided by half as 720 degrees, right? I hope you understand how we got this formula. Let me give you the general formula first of the sinusoidal function, and then from there we will relate the relations. The general formula is y equals to a sine k x minus p plus q, right? So in this general formula, k gives you number of waves in 360 degrees when you're working in degrees, or number of waves in 2 pi, and therefore time period is equal to, let me write here, time period t is equals to 2 pi divided by k, or 360 degrees divided by k. So we have used that formula, correct? So first step is to find time period. Now once you find time period, you need to divide your x-axis based on this time period. My suggestion is divide it into quarters, right? So let us divide into quarters, and each quarter of 720 will be your quarters, right? So for dividing into quarters also, what we should do is we should see what is the minimum scale. Now here phase shift is 30 degrees. Now if I divide 720 by 4, half is 360, half of half is 180, then 30 degrees is 180 has to be divided into 6 equal parts. So let us take 3 equal parts and then we will see how to do, right? So one quarter we are taking 3 equal parts, so that is first quarter, 1, 2, 3. Then again 1, 2, 3, the second quarter, 1, 2, 3, third quarter, 1, 2, 3, fourth quarter. So we got 4 quarters, and these 4 quarters give us one cycle of 720. So that is 720 for us, 720 degrees. Half of 720 is 360 degrees. Half of 360 is 180 degrees. And this number will be 180 plus 360, right? So 180 plus 360 is 540 degrees. So that is how you get your x-axis. So let me say this is my x-axis, the independent variable x. On the y-axis, we need to take care of the amplitude and the translation, vertical translation, which in this case is 2 over 3. So that means each division should be at least 1 over 3, so that we can easily count 1 over 3, 2 over 3 and things like that. So we'll keep each division as 1 over 3, right, to begin with. Anyway, so we got 4 quarters for our sine wave. So first step, as you see, is to find the time period, and then based on time period we divide our time axis or independent variable into 4 quarters as shown here. Now in the first phase we'll actually draw 2 waves to show all the transformations. In the first wave we'll take care of multiplication. That means we'll sketch the function y equals to 2 sine half x. And in the second phase, we'll take care of translations, right? So multiplications first, translations later. And then we'll do y equals to 2 times sine of half of x plus 30 degrees plus 2 over 3, right? So in the first phase, in the first graph, we are going to sketch the graph of 2 times sine half x, right? So we have already considered half x by taking the time period as 720. So half x gives us the time period. We are divided into 4 equal parts, and now we'll begin by placing the 5 key points. So sine function is defined by 5 key points. You know, sine wave is like this, right? So these are the 5 key points which we are going to consider. Now, our amplitude is 2. If each scale is 1/3, then how much is 2? So 1/3, 2/3, and this is 1 whole, right? So this is 1 for us. So 1, 2, 3, that is 2 for us, right? So 1, 2, 3, that is 3 for us. So this is 2 for us. Similarly, 1, 2, 3, 1 for us, minus 1, 1, 2, 3, minus 2, right? So that is our vertical scale. Sine function always starts with the x's. So 2 times sine of half x, we get a point here. Then next quarter, we get the maximum, and then 0. And then, so each and every quarter, do you see that? We are placing our points, and that is one sine wave. Do you see this wave? This is one sine wave. And these are my 5 key points. Each key point is on the quarter of the cycle, right? So each quarter of the cycle. So we can join them and say this is our sine wave, and that is the sine wave which incorporates stretches and compressions. Perfect. Now in the second phase, what are we going to do? We are going to do translations. So translation, because of 30 degrees, this is 30 degrees left, right? And this one is 2 over 3 up. So these are the two translations which we have added to the given stretched function. Okay, so every point 30 degrees. Now what is 30 degrees for us? 1, 2, 3. 3 division is 180 degrees. So 30 degrees, each is 60, right? 60, 120, 180. Half of this is 30 degrees, correct? So we have to move left by 30 degrees. That means half of this, and up by 2/3. So we'll move up. Let me show you in the light color first. So we move half unit, which is 30 degrees, and 2/3 up, 1/3, 2/3. So the points get transferred. Do you see that? So we move half and up. So these are my new points, half and 2. Do you see that? So that is how the wave gets transformed. So half and 2/3. Joining these points will give us the final sine wave, right? So we have the sine wave, which is going to be like this, and then we have to join this point with this, and then this. Do you see that? This gives you the final function, one wave for the given function, correct? So that is how you should be sketching your sine functions. As you can clearly see, this point here is minus 30 degrees. So what is the domain of this function? Now we can write domain of the function. So domain of the function is that x belongs to real numbers. Only one cycle, I'm saying, right? Where x is greater than equals to minus 30 degrees and less than equals to 30 less than 720, which is 690 degrees. As far as the range is concerned, range is equals to y belongs to real numbers, and the values of y are between 2/3 less than 2, right? So 2/3 less than 2. So we could do 2 minus 2 over 2 over 3 since we moved up, right? So minus 2 plus 2/3, you can say, the minimum value plus 2/3 moving up. So that gives you minus 6 plus 2 or minus 4 over 3. So let us check, is this 4 over 3? Yes, it is, right? 1/3, 2/3, 3/3, 4 over 3. That is minus 4 over 3. So the minimum is minus 4 over 3 and the maximum is 2/3 more than 2, right? So if we divide into 3 portions, this will be 6 over 3, 7 over 3, 8 over 3. So that's another way of getting it. So it is 8 over 3, correct? So that becomes the range for this function. So that is how you should be drawing, and see how simple it is. So let me summarize here. Whenever you are given a transport function, use the value of k that is horizontally stretched by a factor of 2. That means the time period instead of 360 becomes 720. Divide this time period into 4 equal parts, which we did, right? 4 equal parts. Once you've done that, take care of vertical stretches. Now vertical stretch here is 2. That means amplitude becomes 2. So draw a sine wave with amplitude of 2 and time period of 720. Now the final sine wave is drawn by taking care of translations. Horizontally translate 30 units, 30 degrees in this case, left, and 2 by 3 units up. That gives you the graph in green, which is the final graph. I hope these steps are absolutely clear. Adopt these steps and see how easy the rest of the questions can be. I'm Anil Kumar. Subscribe to my videos and learn a lot. Thank you and all the best.